Morning, all. Now, we have already seen four videos about artificial intelligence, machine learning, supervised learning, unsupervised learning, and we have also experienced a lab using IBM Watson. That how we can analyze the data using IBM Watson. Now, let's see another practical for another data set in a different way. We've already seen in the previous lab that how we can configure the catalog, what is the catalog, how you can use the services. So we'll simply start with the Watson Studio this time, and we will not go through the previous learning. We have already logged in, and from the resources list, we are starting from the Watson Studio. So the Watson Studio is beginning. It will take some time. Then we launch in. So there are two options for Watson X and IBM Cloud Pak for Data. So we again choose this IBM Cloud Pak for Data. And very soon we'll be seeing the services of generative AI of Watson X also. So keep on watching the videos, the theories, and the labs. When we learn this Watson X, it would be more interesting. So we choose the new project, then we click on next. And this time, what we are predicting is we are predicting for a disease, monkeypox. That are the chances for monkeypox. So it is already having the storage, cloud object storage, Watson X University. The prediction is we say prediction of monkeypox. We will see restrict as a collector, create, click on create. The new project is being created in the same way we did for the previous one, and then we go for an asset. We search for the data file. In our data file we have a data for, let's see, by the name of monkeypox. So we take this data. So depending upon the speed, the data got accessed over here, and this is our data. Let's see what are the fields in the data. So a numeric data which says that two values 0 and 1, 0 and 1, that whether you are having a pain, you are having a sore throat, oral lesions, solitary lesions, swelling tonsils, HIV infection, sexual transmitted infection. So if what are the chances for monkeypox? Prediction giving on 0 and 1. 1 means that for this you can have monkeypox. 0 means that monkeypox is not there. So it is a sample data of 1000 rows. Similarly, we can visualize over here. The data can be visualized, which is a very good feature from which we get from Watson over here, which you can use for your projects, for your papers and all, that which columns you want to visualize for a scatter plot, for x-axis, y-axis, whatever you uh, want to plot. For example, you say that you plot for monkeypox and correlations. So what is the scatter plot? What is a line plot for these things? You can easily plot for it. So coming back to our project of this, and we have already seen that how we can add the data. Then after adding the data, we click on new set asset, and again we click an auto AI. So we are using an auto AI model for this, and we name the project with monkeypox. So let's correct this spelling. It will give a better view. The description we already know. It says that associate a machine learning service instance. So we associate a machine learning service instance again. What's the next machine learning service instance? 8 CPU, like we did, and then we click on create. So simple steps we are following. If you follow these steps, you can use it for any data you wish. Now it is again asking that you want from your data. So we say we will take the data from the project data asset we are already having, and we select our asset for this. So it says you want time series analysis. Again, there is no need for time series analysis. Your prediction over here is on monkeypox, that whether you are having a monkeypox or not. Now see, it was having only two values, 0 and 1, so it choose the binary classification for itself. Again, experimental settings is where you can work a lot. So binary classification, we have to choose regression, time series analysis. So depending upon the data, in the previous data you have must have seen that all these features were not enabled. So in this case, if you want for regression, time series forecast, time series anomaly, the time series is not required. So positive class means the value 1, it is a positive class. Now we're here in the previous video, in the previous lab, we optimized for accuracy. Over here, let's us optimize for ROC curve, and optimize algorithms run score only, score and runtime. So we are algorithms are being optimized for both things, score also and runtime also. And in the previous we choose all the 12 algorithms. Over here let us remove certain algorithms in our searching, that we are not searching, but instead of twofold we are saying that we are saying all the four algorithms, the best four algorithms should come into the picture. Then for fairness, so we say that let us enable the fairness evaluation. Fairness evaluation should be there, and specify the class for prediction. So we already know, and it is auto. We have chosen it. Auto AI it will do. Time series is not there. Then data source. Now what is data source? It is already duplicate rows, we are saying that it should be dropped. Pipeline subtraction method, feature removement, we say for features with no impact, remove those features. These things we have not seen in the previous lab, therefore we are using it in a lab. So we can say that we can remove the features which have no impact on the model. Then leave this thing, text featuring engineering, automatic number of vectors per column. Okay, training data only on training and holdout data. So we are saying that we are using both training and holdout data, and holdout outliers, and how much data should be used for holdout, how much data. So instead of 90% split, we say that 80-20% let us take for this. So we are saying that 80% is training data and 20% is for testing data. And the columns, it says that how much columns you want to use. So these are columns we are taking. We are removing HIV infection, that we do not require HIV infection, and we save the settings for it. So this is how we can save the settings. Now let's run the experiment, and we have chosen all the four algorithms and did certain changes, even changed for the optimization. So it will take little time for running depending upon the data set and the internet speed. We have chosen large number of algorithms, so it will be taking more time as compared to the previous experiment which we did. But let's see what results it give. We can swap the view for better understanding that what is it doing. So in the meantime it is reading the data set. But it is a lovely experiment. You see that instead of making all these algorithms and all, this auto AI is already there. It has already learned the things. We just have to import the data and see that which algorithm is giving the best results. And after doing all these things, we can save this project in our notebook, and we can use it with Colab or other things, and test it with other data sets. The same model can be tested with other data sets. So it will take approximately 3-4 minutes to run. 49 seconds, 70 seconds have already passed, so we are done with 1 minute. So let's wait for another couple of minutes. In the meantime it runs, and if we see the pipeline comparison is not visible for the time being, but swap view, we can swap that what is happening. We'll be able to compare the pipelines once the data is finally run, because we have chosen that all the four algorithms, the best four algorithms to be chosen. So it will take much larger amount of time as compared to the previous experiment. So let's wait. Now see, the data has already been read, and if we swap the view, it shows that 80% is training data and 20% is holdout data. And now it is selecting the algorithms. Approximately 3 minutes it took to load the data, to train it, and now the algorithms are being selected. It will take pipelines and covering for ROC. Yes, and it will give us Snap logistic regression is for the time being optimized for ROC, giving the best results. Though the results are not so good, it is only 44% in this case. So it is searching the algorithms. So let it search, then we will see what the output comes. So having seen all these things, now we are having the results, and it took, you can see in this time elapsed 5 minutes. So within these 5 minutes, 14 pipelines have been generated, and experiment has been completed, and we are having a best result of 50%, you can say, ROC. So we all of us know what is this ROC curve, and uh, which is optimized for binary classification. So we can see that a snap logistic regression is giving the best result in this case. Then we have got a snap VM classifier, then a spam snap decision tree classifier, and last is this random forest classifier. So over here we have seen the four best algorithms which is working for this case, which is optimized for our, for this ROC optimized. And you can save it as a notebook, or you can save it as a model. Whatever way you want to save, you can save it as a model in your program, or it will take certain time when you save it. So it has been already saved. Even if you wish, you can save it as a notebook. Saving it as a notebook gives you a feature to import this notebook in your system and open it with a Jupyter and Colab and Google Colab, and run it as a project you can use for other methods. So keep on learning. You can compare the pipelines over here for different pipelines which have been generated, the 14 pipelines conversion. So you can see over here that how the graphically thing have been plotted, and how you can use it for your papers, for your research work, for your learning work, that how much this pipeline, how much accuracy has been given. So these are the way we can use this Watson for our learning purpose. Thank you.